All right, let's get started here. If you're just joining us, welcome to our webinar on quickly identifying and resolving Kubernetes production issues with Logz.io. A couple of housekeeping items. We will be taking questions after the webinar, so feel free to enter any questions you have in the chat room throughout the webinar. We'll also be sending out a recording at the end. So if you need to get up for a cup of coffee, no worries at all. All right, let's get going here. So my name is Charlie Klein. I am a product marketing manager at Logz.io. I'll be giving this webinar. Just want to go through a quick agenda. First off, we're going to put things in perspective in light of the COVID-19 outbreak. Then we'll go through some challenges to Kubernetes monitoring. After that, we're going to go through how to send Kubernetes telemetry data. I need to do that before you start monitoring it. Then we'll go into a Logz.io demo where we're going to learn how to isolate, identify, and troubleshoot production issues in Logz.io. After that, we're going to have a QA session where I'll answer all your questions. All right, let's get started here. All right, so first things first, why is Kubernetes observability relevant and important in light of the COVID-19 outbreak? So this webinar was actually scheduled before, it really became a worldwide, a pandemic. And for a moment there, I wasn't sure whether I should proceed with the webinar. I wouldn't want to be insensitive, but then I quickly realized that, Kubernetes observability is more important than ever for a whole lot of engineers out there. Some obvious ones that come to mind are healthcare, health tech, the ones actually fighting the outbreak. Collaboration and remote working companies are going to also expect a big bump in usage, and the same thing for gaming and game tech companies. So for some, it's Kubernetes observability is more relevant than ever. So let's start talking about it. First, I'll be quick here. I'm sure many of you are familiar with the challenges in Kubernetes in monitoring Kubernetes environments. So the first one is rapid code deployments, right? Kubernetes really allows you to accelerate your CI/CD processes, and it can be hard to really understand where your telemetry data, so your logs and metrics, is coming from, especially when you have all this new code coming in every day, right? The idea of Kubernetes, one of the ideas is that you can deploy every day rather than every quarter or every year, and so it can be tricky to understand, which code and which parts of your application stack are generating what kind of data, and how you're going to send that data, how you're going to analyze that data. And next, another problem is that Kubernetes just adds another layer of complexity and communication. So with new containers being created and killed so quickly, they're all talking to each other. It can be really difficult to track that communication and track when containers are being created and killed, and how does that affect your ability to observe your environment, right? It adds another layer of complexity. And thirdly, another key reason why anyone would want Kubernetes is that it allows you to scale your microservices, and the more the quicker you grow your environment, the more logs and metrics it's going to produce. And so it can be very hard to separate all the noise from the information that you actually want. So those are kind of three core challenges. Those are the challenges that we'll try to address today. So I'll quickly go through some of the popular solutions to those challenges. The most popular ones are open source, right? And it's not even close. So ELK Stack, Grafana, Jaeger, Prometheus. Why is that the case? Well, first, they're accessible, right? Everybody knows about them. Everyone knows how to use them, and they're free, right? We like free. Another reason that it's community driven, and so all the best engineers are involved in the open source community one way or another, and it's cool to be a part of that community. If you look at the impact that Jenkins, Kubernetes, Docker has had, it's very clear that open source and the open source is on the cutting edge of of technological innovation for application delivery. Thirdly, it's DevOps native, right? It's a whole lot easier to integrate your open source tooling into your DevOps workflows than it would be any proprietary tooling. And if you don't have that integration, you can just easily build it yourself. And then lastly, it's cloud native, right? So all of the, many of the technologies that made the cloud what it is today are open source. And so just a couple of reasons why open source is, by far and away the most popular and familiar way to gain observability into Kubernetes. While that may be the case, open source can introduce new burdens. One of those is that there are no open source solutions that can monitor your logs, metrics, and there are no open source solutions that are purpose built to monitor your logs, your metrics, and your traces. Right? You have the ELK stack, purpose built for logs. You have Grafana, purpose built for metrics. You have Jaeger, purpose built for traces. But when you have multiple different tools to gain observability into your environment, it creates the siloed data, which we see in the middle, right? The siloed data leads to disconnected insights about what's actually going on in your environment. So if you identify an issue in your traces, you might need to explore that issue in your logs to investigate it. And if you have two separate tools to do that, it makes it a lot longer to actually understand what's going on, right? You have to navigate between different interfaces, run different kinds of queries, to be able to identify and resolve and really explore those production issues. Thirdly, open source requires ongoing investments. What I mean by that is, as you scale the amount of logs, metrics, traces you're sending, it's going to take, it's not as simple as just, sending more data, right? You have to build buffering system, processing systems so that your monitoring tool isn't overwhelmed, right? Too much data will crash the application, and that's not doing anyone any good. And so you need to, especially with the ELK stack, you need to really build a robust data pipeline in order to scale, in order to scale out your monitoring system. All right, so I just want to quickly show how to send data from Kubernetes to Logz.io. I'll start with Microsoft Azure, then I'll go to AWS. So here on the left, you see you have your Kubernetes cluster and your applications on Kubernetes. There are a bunch of different ways to send your data to Logz.io. It's not too complicated. One option, most of our customers on Azure are sending all their data to Azure Event Hubs. We have a deployment template with Azure. And so you just hit deploy from the Logz.io application. It creates a configuration template in Azure, and it allows you, it makes it very easy to collect all of your events from your Kubernetes cluster and applications in Azure Events Hub, and then you simply forward that information with Azure Functions over to Logz.io. Every 5 or so seconds, you get to determine. You can also archive all that information in Azure Blob. Another way to do it is to send it to those open source agents I have at the top there above the Azure deployment template. So you see FileBeat, MetricBeat, FluentD. FluentD is definitely the most popular way to collect and send logs and metrics over to Logz.io or any other observability tool. It's just an open source agent, runs right next to your cluster, and it's pretty easy to configure. Move on to AWS here. It's very similar, right? So you have your Kubernetes cluster, your apps on top of AWS, on top of Kubernetes. You can ship all that data to CloudWatch rather than Event Hubs. And then we have a Lambda log shipper that works a very similar way. It just forwards that data collected in CloudWatch over to Logz.io, and Logz.io listeners will pick it up, and then you can monitor it in our log management system, our log management tool based on ELK, and our metrics monitoring product based on Grafana. You can also use those same lightweight open source agents that you see on the top. And the third way to do it is just to ship it all to S3 buckets, and then Logz.io can just pull that data from there. So many different ways to do it. I would recommend exploring our documentation on just there's some other ways I didn't list here. It might be more convenient for you. All right, let's get into the Logz.io demo. So what we're going to do is we're going to go through 3 different ways to identify and resolve production issues with Logz.io. So this is after you sent your Kubernetes log and metric data to Logz.io from AWS or Azure. You can then analyze it in our platform. So let's take a look. Make this full screen. All right, so the first way we're going to identify and troubleshoot a Kubernetes production issue is just with our logs. So you can see we have almost 2 million logs generated in the last day from our Kubernetes cluster in this demo environment. Obviously, scrolling through these logs to identify specific problems is impossible, right? It's crazy. And nobody does that for a reason. It would take too long. You can add queries up here, just like you would in Kibana. However, it still doesn't, limit when you don't know what to look for, which you probably wouldn't if you think something wrong is happening. It's still incredibly hard to find logs indicative of any production issues. So what we can do is just hit patterns. Patterns is something we've built on top of Kibana, which clusters similar logs together based on patterns identified in the message. So here we can see about 370,000 logs. About 20% of all of our logs are proxy request logs. And if that's not important to us, we can just quickly filter that out. And just like that, you can see that we reduced almost 20% of our logs in this query to kind of refine our search. So if we keep scrolling down here, we can keep on filtering out data depending on what we're looking for. And as we go down, we can see something that kind of sticks out. It's this Java stack trace exception. And so clearly this is something we'd want to explore. We can filter it in just like that. Now we're left with all these Java stack trace exception issues. We can see that it just started happening within the last couple of hours. Open it up, explore it a little bit. It's very clear what the problem is. And if we didn't have the ability to cluster all those logs together, we never would have found this, right? We wouldn't be able to find this kind of, it would be, or at least it would be a lot harder to find these logs indicative of production issues when you have a list of 2 million rather than a list of 40 or so records. So that's one way to identify and kind of explore production issues generated by our Kubernetes environment. I'm going to clear these. Filters here. The second way to find Kubernetes production issues, to identify them, is in our metrics solution. And so we're gonna navigate over to our Grafana-based metrics monitoring solution, and here we can see a whole lot of pre-built dashboards, pre-built Grafana dashboards that we built to monitor different kinds of popular cloud technologies. So if you see any technologies that you'd want to monitor here, all you'd have to do is open up the dashboard, and once you send the data up, the dashboard will automatically begin populating. And we're continuously building new products, new dashboards, every week. And so this is just going to expand. So in this case, let's check out our Kubernetes cluster dashboard. That's the data we sent. So this is all information that is typical information that you want to know from your Kubernetes cluster. We have 25 running containers. We can add new panels just like you would in open source Grafana, and you can edit panels, edit existing ones in the same way that you would with open source Grafana. So if we scroll down here, let me just clear these filters. We can see that something is spiking in our CPU and memory usage. It's pretty clear right away that it's this Nginx container. We can see that it's clearly using up a whole lot more CPU and memory than the rest of the containers. So we can filter for that by clicking on them, get a more granular view of what's happening. So we can see that this deployments, these purple markers represent deployments, and we mark them automatically based on the logs that you're sending us. So when you have, say, I don't know, a successful Jenkins build, it deploys through your CI/CD pipeline into your Kubernetes environment. It'll send us a log, and we'll identify that log and automatically mark the deployment. So we can see that this spike in metrics happened right after this deployment. So clearly, this deployment caused something funky in our Nginx container. So metrics are great for seeing that there is a problem. What we need is to troubleshoot the problem now, right? We need to explore this issue to figure out what's actually going on. To do that, we need more descriptive information of what's happening in our environments, and we can find that information in our logs. So what we're going to do is explore this issue in Kibana. And that's going to take us over to our log management solution, and it's going to show us all of the logs associated with that same spike in metrics we saw in Grafana. So just like that, you can see how we are able to correlate the logs that are relevant to what we see in our metrics. And so it's immediately clear that we're looking at that same Java stack trace exception that we looked at earlier, and that is causing that Nginx container to spike in CPU and memory usage. So if we had two separate solutions for log analytics and metrics analytics, we would not have been able to so quickly correlate the data like that. We would have to go to our Kibana dashboards, run a couple queries, try to find the logs associated with those metrics. But by providing the two solutions on one platform, it's very easy to do very quickly. All right, so that's the second way. That's the second way of identifying production issues in your Kubernetes environment. Now we're gonna explore a third way. So the third way is by using something called cognitive insights. And so that's just a tab right here that we can open up. And let me change the make this a bit longer. A couple more options. So, there we go. Last day. So we can see in this tab called Insights, another thing we built on top of Kibana to make it faster and easier to identify the logs that matter most to you. And so if we open this up, let's just hit SQL. So that's going to pull up all of the logs tagged with this SQL Insight. And so if we open it up, you can quickly see that it's an SQL syntax error. Again, that's something we wouldn't have been able to find if we didn't have insights. It would take a long time to scroll through all of our logs to identify this kind of problem. So we identified this SQL syntax error by cross-referencing all of our logs with online forums such as Stack Overflow or GitHub to predict what's going to be most important to you, to the engineers. And so when we see this log, we can see that it was also the same log was discussed on the Stack Overflow discussions. And so that's how we were able to predict that this is probably something that you would want to investigate as well. And so that's how you can, really quickly begin investigating issues. We can even open up the log here or the link here and see that it's this to see how other engineers resolve the issue. So that's the third way of identifying and troubleshooting production issues in Kubernetes. And so the name of the game here is to be quick, right? And by adding these different features on top of Kibana, by integrating Grafana with Kibana, we're able to very quickly first identify the issue and then troubleshoot it using our logs. And it's that quickness that's going to be the difference of whether or not your customers are going to be impacted or not. And that was what I was trying to show you today, is just how quick it is, right? How quickly you're able to navigate your data and correlate your data to troubleshoot problems before something bad happens. All right. I think we're ready for some Q&A. Just a quick recap. So the first strategy for identifying and troubleshooting production issues is to identify the metrics indicative of the production issue and correlate it with the logs to troubleshoot it. That's what we saw when we went from Grafana to Kibana. The next strategy is to just scroll through your log patterns to quickly identify logs indicative of production issues. That's how we first found that Java stack trace exception. And then the third one is just check out the insights. Pretty easy. Just drop down in the insights tab and see what kind of issues have been, what kind of logs, what kind of logs that you received have also been discussed in online forums. So those are the three ways that I wanted to cover today of how to quickly identify and then explore production issues in Kubernetes. All right, so some next steps. You can check out our blog if you are, if you're working to combat the COVID-19 outbreak. You'll see our plan to help you. We'll give you a free offering of Logz.io to help combat the outbreak. If you check out our blog, you can learn more about that. You could also sign up for a free trial. You can send some of your own data. I think it's a gigabyte cap per day. Or no, it may be 3 gigabytes, and then it's a few days retention. So you can keep your data for a little while, see how you like, see what it's like exploring that data on Logz.io. You can check out the Logz.io Academy to learn more about how to ship data, how to analyze it in Logz.io. And then you can also look at our docs if you want to get a better idea of how to use the API, how to ship data from your specific environments. There's a whole lot of good stuff on there. All right, questions. Let me open these up. Okay, first question. What is the best way to send Kubernetes logs to Logz.io? So there are a few ways to do that. For logs, I think the easiest way is to use FileBeat Auto Discover. It automatically will identify new containers as they're created in your environment, and it'll automatically create the necessary configuration to send the logs from those new microservices to Logz.io. It's very quick and easy to do. You can see it in our docs. There's actually a recent webinar on it too. And a blog as well. So there's plenty of ways to learn about that. That's a common way to do it. Fluentd is another very common way to do it. This one's a bit of a long question, so give me just a moment. Okay, so I think the gist of this question is that is asking whether you can correlate. Okay, yeah. So it's just like we saw how we were able to correlate metrics with specific deployments in Grafana. So the question asks if we could do the same thing in Kibana. Can you correlate logs with specific deployments in Kibana? And the answer is yes. We have something called application insights that allows you to understand which logs, or rather which insights, which cognitive insights, so potential issues in your environment were created by specific deployments, or rather were or as a result of specific deployments. Looks like the blog on FileBeat Auto Discover isn't quite easy to find, and so yes, I can share that. Yeah, you know what? I can share that with I can Okay, there's a follow-up question there. If you just go to our website, the blog is very easy to find, and from there you'll be able to you'll be able to find the blog I was referring to. All right, everyone. Looks like those are the those are all the questions we had. Thanks so much for joining. I hope you learned something. Feel free to check out our blog to learn more. Thanks, everybody, and stay healthy. Take care.